Hello, this is my submission for coding assignment 1, map coloring constraint satisfaction problem. In this video, I will be going over my algorithm, running my code, and showing the output. So in order to represent a map coloring problem in Python, I opted to use an adjacency matrix. In this matrix, each row and each column represent a province, and the indices of each province can be seen here, right? So row 0 represents Alberta, and column 0 also represents Alberta. So each entry, as you can see, is an integer, and there is a key here for what the integers mean. So a value of 0 means the provinces are not adjacent. So you can see that Alberta is not adjacent, for example, to Manitoba. Or sorry, Manitoba is not adjacent to Alberta. -1 means that the provinces are adjacent, but the province of the column has not been assigned a color yet, right? So here we know that Alberta is adjacent to British Columbia, but since this is the beginning of the program, nothing has a color yet. And then once we assign a color, it will be a positive integer. So these entries will turn into positive integers. That would denote that these provinces are adjacent and the province of the column has been assigned a color. So to start, we initialize a list of zeros, which we then will change with the color integers of the corresponding province, right? So once we choose a color for Alberta, let's say 2, we will put 2 at the 0 index of this array. We have this user interactions script that basically just gets the user to input a list of colors, space separated. And you will see that later in action. And then it will return a list of those colors, right? Let me go back. So there's a list there. And then we also have a set called total colors, where for each string in color words, we will assign it an arbitrary integer value starting from 1, right? So whatever color the user chooses to input first will have the value 1, the next one will have the value 2, and so on. Now that we have all our variables, we can go into the algorithm. So you can see the algorithm is going to go over each row, right? So each province, and for each province, we create a set that is called possible colors. So possible colors to fill this province, or to assign to this province, which is just a copy of total colors. Then we loop over each element in said row, and we consider the entry at that position. So if the entry is more than 0, which means that there is an adjacent province at that position that has a color, that means we are no longer able to use that color. So if there is a color at that position, we will remove that color from our set of possible colors. Once we will go over each element in a row, we will check if we have any more colors remaining, right? So if possible colors is empty, we say that we can't solve it with this amount of colors and we exit. Otherwise, we convert the possible colors set to a list so we can access the first element. And we will use that first element to color in the province, right? So if we go over this whole row and we see that there is no adjacent provinces with any colors, we will convert the set to a list. And let's say the first element of the list is 1. So that color 1 will be the color for Alberta. And you can see here that we are using color in 2 places. We are using color to assign it to this array I've mentioned earlier, right? To keep track of what color each province is. And then we're also assigning it to each entry in the specific column we're looking at, right? So for example, if we are on row 3, we're talking about Manitoba. We choose to assign Manitoba the color 3. We will then go into column, this is row, row 3. So row 3, we'll then go into column 3 And each time Manitoba is adjacent to something, we will assign it the value of 3. So this can be referenced later for the next province, right? And that's basically it. That should fill out all these values. Then we do some, this is the end of the actual map coloring algorithm. Then we just do some formatting, right? So we convert, we use this array of integers and this array of the strings to create an array of string representations of colors, right? So now at value 0, for example, we won't have 1, we'll have red for Alberta, right? And so on. Then the province strings and the color strings are zipped into a dictionary. The dictionary is passed on to color map. So before I go over color map, I will actually run the program because it takes a little bit of time to run. So we'll run the program here. Here we go. So enter a space-separated list of colors you wish to use. Enter complex colors with spaces, right? You can see dark olive green is just one word. This is where the list of colors comes from. And let's say I want to use red, blue, green, orange, for example, right? So it tells me 4 colors have been recognized, and it calculates. Then this may take around a minute, so that's why I ran it first. So for color map, the way we display the colored map of Canada is I use a shapefile of all the provinces that I got from the Government of Canada website. So this utilizes GeoPandas and Matplotlib to read the file, then turn it into a plot, and then fill it in with the appropriate color. Right, so remember we passed in a dictionary. We use that dictionary to color in each province, and we use this attribute to check the name of each province. I think this is just English name. I was using just name before, and I think it includes French names, so it wasn't working for some of the provinces. But this is just English names, and so this will find all rows where the English matches the province name, and it will fill them in with the color we chose. And it just plots. This is just how long it took. So you can see here it took 50 seconds, right? It gives us an option to save it to our computer. I don't really want to right now, but you can do that. And there's the map, right? So you can see it's pretty detailed, even though it has been simplified quite a lot. I found that if I simplify it further, some of these borders start to like disappear. Like there's just gaps between provinces while all this stuff is preserved. So that's definitely something that can be worked on. But yeah, there you go. That is the output, and that's it. Thank you.